So this stuff is function notation. You may or may not have done this in algebra. I think it's covered in algebra, but if it's not familiar to you, that's okay. It's not terrible. It looks like it's really complicated, but it's less complicated than it looks. So basically what it is it's just a way to kind of change an equation around that you already have to make it a little bit less confusing, even though it seems more confusing because you're adding extra stuff to it. Let's say we're working on something, I don't know, a project or something where we have to use all of these equations here, and they basically, they're all mean different things. They're not just random ones I came up with, they mean different things. But say maybe you're writing a lab report, or you're doing something in science, or it could be even something in math, and they give you all these equations, and you're going and solving, and then you're like, okay, well, I know when x equals 5, y equals 85, but then I go to this next problem here. If I put a 5 in, then I get a different y, and it's kind of confusing having everything as x and everything as y. So what they do instead of just using x and y all the time is they'll switch it to this function notation. So here, all they're doing with this first equation is replacing the y equals with an a of x equals, okay? And usually whatever these letters are out front, they just kind of represent something about what it was up there. So like that one has to deal with angle measure, so that's probably why they used an a. And that next one has to deal with temperature, so that's why they probably used a t. Those just kind of help you, if they're talking about different equations, it helps you to identify which one they're talking about, okay? This is called function notation. How you read this, so this would be a of x, so anytime it's in like that little parentheses thing, you just read it a of x, or like in this case it would be f of x because it's an f out front. What else was I going to say? They'll specifically tell you like what you're plugging into these. So if they say, okay, x for this one, they'll use something with the a. If they're saying x for this one, they'll do something with the t. X for that one, they'll do something with the l. It's just a way to try to avoid mixing up the equations when you have similar letters in there. These don't mean multiply. So a lot of times people are like, oh, it must be whatever my L value is times my X value. This does not mean multiply, okay? And if you need to write a little note to yourself like, hey, not multiply, that might be helpful. But basically, it's just kind of a different way of writing the Y out, basically. Okay? And we'll do some solving here on the next one, so you kind of get that. So here, and this should be on your little example packet. Everybody got one of those still? Okay. So this one here, we've got T of F, okay, so this is a temperature one again, just because it's got a T there. And then it says is equal to 5/9, and then they've got F minus 32. This is the formula for converting degrees Fahrenheit to Celsius, if you were wondering on that. And then they say we're supposed to evaluate T of 86. And again, it doesn't mean T times 86. What it means here is our F value is 86, and we're going to plug that in for the F values in our function, okay? So here, if I'm trying to find T of 86, I'm just going to put an 86 in there for the F. Then when I've got my little function, I'm just going to take that same 86 and put it in for the F. So I'm going to go 5/9 times that 86 for the F, minus 32. And then we're just solving this side out. This side is just telling us that we're finding our temperature value when our Fahrenheit is 86 degrees. This part we don't do any solving with, okay? We only solve this side. So if we are solving this side, what would we do first? Yeah, do the parentheses, and we do that subtract first, right? So if we do that, 86 minus 32, say it again. 54. And then we'll take that times our 5/9. Do you guys remember how to do that on the calculator, the fractions? I'll touch on it again. So you could do our fractions, put that over 1, do our cross reducing and that kind of thing. If you've got one of these calculators, it's easy to multiply fractions on these. So what I would do is I would take this 5/9 and I'm going to put it in parentheses. So I'm going to go parentheses. 5 divided by 9 parentheses. That makes my fraction. And then I'm just going to take that times 54 is our number. And then just hit enter, and it tells me it's 30. a little review on that as well. So then we'll have T of 86 is 30. So that's telling us when our temperature is 86 degrees Fahrenheit, it's 30 degrees Celsius is what that formula is telling us. Does that kind of make sense? It's very similar to just equations. Okay, a little bit more to write here, and then we'll do that next example. Okay, so let's start taking a look at this stuff. One thing I was going to mention that I was thinking about, talking about like our independent and dependent stuff that we were talking about the other day. The dependent is always going to be the stuff that's kicked out still. So this t of f or whatever, that's still the dependent, the stuff that's kind of by itself on the side of the equal. And then whatever value we're plugging in, so like the f value here, that would be the independent. So same as it was before. Okay, so now this mapping notation, if you remember from yesterday, one of the things that we wrote in our notes was that maps or mapping was a synonym of function, so that just means like they mean the same thing. So same here, when we use mapping notation, the writing of it's just a little bit different. So like instead of using like the parentheses and the equal, they use a colon and an arrow, but it means the same exact thing, okay? So if they say, hey, convert something from function notation to mapping notation, you're keeping everything the same, except you're just swapping out the parentheses for the colon and then the equal sign for the arrow, but everything else is the same. The solving is exactly the same too. And then how you would read that out loud, the function f maps x onto y. Okay, so let's do some solving with a mapping notation one then. So they've got let f of, I don't even know how to read these. The function f maps x onto, and then they've got x plus, and then x squared divided by 20. Okay, and then they want us to evaluate a couple things here. One is just f of 10, so we can plug that in, and then the other one is f of s plus f of 10. Okay, so two separate things we're trying. Okay, so let's start with the f of 10 stuff. So similar to what we had before, if that's a 10, where are we going to put that? Yeah, in the spot for the x, right? So we're going to go f and then that colon there. This time, actually, these should probably be different notation here since those are parentheses, but that's all right. So we're going to put that 10 in the x spot, get that little arrow there. Oops, put an x instead of 10. 10 plus 10 squared over 20. So just all the spots where there's an x, swapping that out with the 10. And again, this side doesn't really mean anything to us. That's just our notation. We're just solving this side. So if I'm solving this side, what do I have to do first? The squared, right? So I'm going to take 10 and square it, which is 100. Put it underneath here. So I'm going to go 10 plus 100 over 20. And then from there, divide. So 100 divided by 20. 5. So then it'd be 10 plus 5. And 10 plus 5 is 15. Yep. Or you could put it as, if you wanted to go, the f colon and then the 10 and then the arrow to the 15. Either of those would be fine. Okay, so now what they want us to do is they want us to evaluate a couple things and then add them together. Okay, so we just figured it out when it was the 10 in there, so we've got that answer's 15 already, but now we have to plug in where it's an s, and then after we get those two values, then we're going to combine those together as one. Okay, so let's plug it in where it's an s now instead of the x. So even if it's a letter, you still do the same thing. So you're going to go f, then that colon, this time we're plugging in an s to that spot, then the arrow, s again is getting plugged in, plus s squared over 20. Okay. Now with that, is there anything that we can actually solve out there? No, there's not, because this is an s, that's an s squared, so it's not like we can add them together. That one's over 20, that one's not over anything, so we can't do anything with that. So that's just as good as we can get there. It's just going to stay like that. But then now what we want to do is we want to add that f of 10 that we figured out before. So we figured out that to be 15. So what we're going to do is we're just going to take what we got there, the s plus the s squared over 20, and we're going to add that 15 that we got for the f of 10. And then when we put that 15 with it, can that be paired with any of that stuff to simplify? No. So this, has got out of 20 again. That's not out of 20. That's not out of anything there. That one doesn't have an s or an s squared, so we can't combine anything. So that'd just be our answer there. It's just different ways of doing stuff we've already done. Okay? Okay. All right, so book page here, the page didn't get written, but it's 23 is the page number. And then it's 1 through 21, but we're going to skip number 11, and we're going to skip number 17. Okay, so skip 11 and 17. They say something about like CAS. If it ever says something about CAS, that stands for, I think it's like computer aided systems or something like that. We don't work with those, so if it ever says CAS, just ignore that. Okay? Okay, so working on that book page, and today is our third